Hello, hello, hello. Here's Wojtek, and here you have a AWS Maniac channel. Good morning, good afternoon, wherever you are. Give me a sign if you can hear me. If there are no problems, shout out on the chat. We are starting in 1 minute with the AWS Messaging Services series. This time we will talk about Amazon MQ. Okay, I see that people are reporting that all good. So I think we can start. So let's do a quick reminder what we covered so far. Today is the third episode of our series, and the last 2 weeks we covered Amazon SNS, Simple Notification Service, and last time we talked about Amazon SQS, Simple Queue Service. Today is the third service that we need to cover, Amazon MQ, which is also queuing service, but this time is a little bit different. I already planned 2 next sessions, so on Tuesday, because we've got Monday today, and I changed our schedule a little bit. Sorry for that. If you expected stream on Tuesday, I couldn't make it, but still we have one on Monday. I have planned 2 new episodes in 1 week and in 2 weeks, one about Kinesis data streams and one about Event Bridge. Probably we'll cover next time managed streaming for Kafka, and then maybe I will reverse the order and talk about Message Broker and AppSync and Pinpoint at the end. There's also an idea that I should cover signaling channels from Amazon Kinesis video streams. So if you heard about WebRTC capabilities in KVS, probably you will be interested. But today we'll talk about Amazon MQ. Quick survey on the chat. How many of you heard about RabbitMQ, about Apache ActiveMQ, about MSMQ, and other event buses / queuing systems? Let me know in the comments on the chat, because today we'll talk about such broker. Quick reminder about our goals. So I'm doing all this in a live stream format, so I count on your active participation. Once again, I really count on your comments. I will try to do my best to do the maximum deep dive into those services, especially to cover the topics that are less known or probably you haven't heard about. That's my challenge. And I would like to highlight the proper use cases and compare those 2 services, actually 3 services right now between each other. So we can actually investigate when to use which and what use cases are proper for different services. So enough about goals, enough about series. Let's jump into the service. Amazon MQ is a fully managed open source message broker, which is basically an implementation, productized service implementation of the Apache ActiveMQ open source message broker. If you heard about Apache MQ, you probably know what it is. If you don't worry, I will explain it in a moment. So the full name of the service is Amazon MQ for Apache ActiveMQ, and you can actually see the pattern here when it comes to naming the services, because the same happens with the managed streaming for Kafka, Amazon Key Spaces for Apache Cassandra, and also with other services that are using the open source work and open source services, open source technology. AWS exposed this as a fully managed service, which is basically a broker designed for a hybrid cloud use case. It supports multiple widely adopted protocols like AMQP, MQTT, OpenWire, Stomp. There's also support for messaging APIs like JMS, NMS. It is designed to support high availability and high durability, and also It is built in with scalability in mind, but we've got limited options when it comes to the scalability, horizontal scalability, because it's really hard to achieve when it comes to the queuing systems. But we have some options. We will talk about networks of brokers. The major emphasis is on the low latency and high throughput in some certain scenarios. On the left, you can see the logo, which is pretty similar to the SQS, but you've got multiple circles around the big circle. So those circles probably resembles the protocols that are supported by this service. In SQS, we've got just one because SQS was available over HTTPS. Here we've got multiple protocols that are fully compatible and fully compliant with the official standards, because we are actually dealing with Apache ActiveMQ. So as usual, I covered the whole service in 3 parts. First one, we'll talk about architecture. We'll introduce what Apache ActiveMQ is. We'll talk about building blocks, supported protocols, what are the options for the scaling and pricing, and also what are the use cases. When it comes to the second part, we'll talk about operations. We'll talk about high availability, pricing, network of brokers, scalability, and how to achieve low latency and high throughput. When it comes to the third, we'll talk about best practices. We'll compare those services between each other. We'll talk a little bit about how to migrate Amazon MQ and what are the options. We'll talk about the connectivity, security, and how to build AWS Lambda consumer, because that's also an interesting part and lesser known thing. So when it comes to disclaimers, this time we will have a little bit more knowledge about the underneath service, because Apache ActiveMQ is an open source project. However, Amazon MQ is not an open source technology, so we are actually still dealing with some gray areas, but less gray than in comparison to the SQS or SNS, for example. So our goal here is to discuss the differences between the open source versions, but also to show you that when it comes to the compliance with the original open source version, we are pretty much close and fully compatible with the expected feature set. Maybe the only problem is about the plugins, but I will cover that in the details later. Let's talk about the architecture. So Apache ActiveMQ is one of the most open source multi-protocol messaging servers. It's Java based, so it's basically a JVM technology. It has built-in support for protocols like AMQP, MQTT, which is the lightweight version of the message queuing protocols, Stomp, and MQTT and Stomp can be both exposed over the TCP, but also WebSockets, and also OpenWire. It also supports messaging APIs like JMS and NMS, depends on what side of the programming languages community are you coming from, or Java or .NET. In both cases, you can use it. And there are 2 streams of development currently. There is one called Classic, which is version family 5.x, and ActiveMQ Artemis, which is version 6.x. The biggest problem is that currently the version 6.x doesn't have the full feature parity when it comes to the classic version. So it already transfers to a problematic situation that we cannot use Artemis on Amazon MQ because they are relying on some features and behaviors that are implemented in 5.x. When it comes to the Apache ActiveMQ, you can compare it with the MSMQ, RabbitMQ, maybe IBM MQ, depending on your background and how you used messaging servers in the past, message brokers in the past. The typical alternative for Apache ActiveMQ will be Rabbit, which is Erlang based messaging server. It has pretty much the same the same coverage when it comes to protocols, and the same openness because it's an open source software. So that's all about the Apache ActiveMQ. From now on, we will talk about Amazon MQ, which is basically a fully managed version of that open source engine. You may ask, okay, so Wojtek, it's already a second or third service, depending on how you count, that actually handles the messaging / queuing scenarios. How does it fit into the AWS portfolio? The whole point of having multiple services available is to cover multiple scenarios. So when it comes to the Amazon MQ, the main goal is to support hybrid architectures and hybrid cloud architectures. It's pretty easy to imagine a situation when an existing company has on-premise systems that are having message brokers or message-oriented middlewares implemented somewhere. And if they would like to migrate to the cloud, re-architecting and re-implementing everything to support SQS may be too complicated and too resource consuming. So in order to support those companies into migration to the cloud, they have introduced a fully managed service that actually supports and covers many scenarios when it comes to the messaging servers. It also enables very flexible hybrid architectures, depending if you are using VPNs, direct connect, or you would like to connect two sites together. And the main goal is to cover actually the migration to the cloud scenario or having a hybrid cloud use cases. It is additionally often described as an Amazon RDS for message brokers. That's a very good approximation when it comes to what you can expect from that service and how it behaves. Maybe the main difference is that Amazon RDS has many engines, and currently we have only Apache ActiveMQ for Amazon MQ. So that will be the scope and how this service fit into the AWS portfolio currently. Let's talk about building blocks. So obviously, if we are talking about messaging servers, there must be a broker somewhere. For those of you who haven't heard about this term, broker is basically a message environment that runs on Amazon MQ. And it's a central point that connects producers and consumers. And it's actually a server that accepts the messages, accepts the new messages sent from the producers and expose them to the consumers in a form of either topics or queues, because we've got both options on Apache ActiveMQ. I will talk about this later. When it comes to the broker definition on AWS in Amazon MQ, brokers are region specific, so you need to choose the region first, and the whole service is also region specific. Additionally, when you are creating a broker, you need to define an instance class, and we've got M5, T3, T2 available, and also size like large, micros, and so on. If you are familiar with EC2 virtual machines, that's basically the same naming convention and the same meaning behind those acronyms. Maybe the major difference will be the MQ dot prefix when it comes to the instance type. After choosing the instance type, we can change it, and that's basically a vertical scaling. We can scale up and scale down depending on the needs, but there are some challenges when it comes to scaling, and we will talk about this when it comes to the storage layer. Additionally, we can have single instance brokers and active standby architectures, which allows us to have high availability when it comes to the multiple available zones. Additionally, when it comes to broker itself, we've got several attributes that identifies a broker. So first things first is a name. Then we've got broker ID, which is this kind of a GUI-like identifier. Then we've got Amazon resource name, which is the usual resource name that you can expect from all resources available on Amazon. You can see that there is a region account ID, broker name, and broker ID incorporated in that. And there is ActiveMQ UI, which is basically a URL for the web console for Apache ActiveMQ on the port 8162. And when it comes to those URLs, there is this interesting postfix behind the broker ID /1/2. Those are active standby setups that allows you to implement a failover when it comes to the connectivity between multiple brokers. When it comes to the instance classes, the main interesting part is that some instance classes are actually limiting the options that you can use. For example, if you like to use T2 and T3s, you cannot use EBS because it's limited to only M5s. It's partially related with encryption, but I think the major problem with supporting EBS just for M5s is that EBS is designed for high throughput scenarios. I will talk about this in a moment, but you need to be careful when it comes to the choosing those instance classes. So I would say that changing the size of the across the instance class is pretty simple and does not involve any additional problems. But in many cases, if you like to stay with your high throughput scenarios, you can actually change only the instance size and cannot downgrade the instance classes anyway. And the same rules are applied when it comes to the instance class in comparison to the virtual machines. So instance class and size are actually affecting the RAM, CPU, and network that are allowed and associated with our servers. So bear that in mind, that if you would like to have something that is maybe less CPU intensive, but you need more network throughput, probably you still need a bigger machine, even if you do not use that CPU workload. One important thing about the Amazon MQ UIs that are exposed by those ActiveMQ UI URLs, even that we have two brokers in the active standby architectures, only one is active for a given time. So if you have two brokers, still you will be able to access just one web console, and you need to handle that on your own with some kind of load balancing if you would like to have a single URL for the web console for Apache ActiveMQ. So bear that in mind, that if you would like to have a unified URL, you need to cover that with load balancing. Second building block is engine. And as I said, at the current moment, we've got just Apache ActiveMQ and just the version 5.x. The latest version is 5.15.12, and this one is also recommended because it has all patches applied already. For now, there is no support for Artemis, and as I said, it's mainly because there's no feature parity between 6.x and 5.x. And additionally, when it comes to engines and defining the how those changes can be applied on the engine, you can define a maintenance window and automatic minor version upgrades. And we will talk about broker lifecycle in a moment, but keep in mind that all changes when it comes to the configuration and also upgrades will require rebooting the broker. So it means that you need to define a maintenance window if you would like to have a setup that will not require downtime when it comes to applying changes. So bear that in mind and have the maintenance windows defined in order to have the ability to do it properly and in a controllable way. Third building block that I would like to explain is configuration. And that's basically the same kind of configuration that you can expect from ActiveMQ if you are familiar with. It's basically an XML file, and it's very similar to the configuration idea behind it. It's basically very similar with the settings file that you had in the open source version. And you can create a configuration before creating any brokers and share it to one or more brokers afterwards. So it's basically like, if we will use the same analogy with Amazon RDS, it's like with the parameter groups and option groups. So you can share them between the Amazon RDS instances and clusters. And additional building block that it's very important because it actually defines you how you will operate the brokers and the architecture is storage. You can't change the storage after creating a broker. So this is a decision that basically limits the ability for many things like scaling, doing the setups when it comes to the high availability, and so on and so on. There are three options available. First things first, you can use EFS, which stands for Amazon Elastic File System, which is basically an NFS, network file system, network-based shared storage. Please do not confuse that with EBS, which it's also replicated, and it is kind of available over the network, but cannot be shared over the multiple instances. EBS is like a disk, a single disk attached to a single instance, when EFS is basically a network share. And EFS is a default option. It's persistent and very durable because we've got the same durability guarantees like with the Amazon S3 for regular EFSs. It allows you for a replication across multiple availability zones with a single instance architecture. And it has the lowest throughput from all those three because it requires significant network overhead. Still, it's one of the only options that allow you for a high availability if you will not drop into the network of brokers. Second option is in memory. It's not persistent, rebooting will lose the messages, there's no replication, and there is very high throughput. What is the high throughput and very high throughput defined? So for the EFS, we've got 50 messages per second enqueued per producer. And it's not a big message, it's about 1 kilobyte. So it's not a huge throughput, but still you can do and handle most use cases with the EFS. When it comes to in-memory throughput, you can enqueue per producer 5,000 messages per second, which is impressive. And if your use case can rely on ephemeral data and temporal data, and you don't need replication, why not to use in-memory storage? And last but not least, you've got EBS, which stands for Amazon Elastic Block Storage. As I said, is a persistent and redundant in the sense that it has multiple copies within one availability zone, and it allows you for a high throughput. High throughput in this case, it means that you have 500 messages per second, again, enqueued per producer, and we are talking about 1 kilobyte messages in size. The major drawback for the EBS is that it requires at least M5 instance class, and it doesn't work with active standby architecture. And you can imagine why, because if you would like to have active standby, you need to actually have a shared disk between two instances in different availability zones, which is impossible on AWS. The only way to achieve that is to have EFS. So if you would like to have high throughput and multi-AZ availability and redundancy, there's a huge challenge in front of you because you need to implement the network of brokers with some snapshotting and restoring capabilities, and you will not have the full guarantees when it comes to the replication and consistency. But I will talk about that in a moment. And last but not least, the final building block is a user. In this sense, user means a person or application that will access the queues or topics from ActiveMQ broker, and you can configure users to have specific permissions, and it's fully in line with the ActiveMQ capabilities, like support for Java for authorization and authentication systems, or even simple configuration credentials. You can connect it to the Active Directory, to the LDAP. You can have authorization over the users, groups, anonymous access, read, write, admin, and so on. All those capabilities that are supported by ActiveMQ are supported by Amazon MQ as well. When it comes to use cases, I think the most interesting ones are listed here. Skip the dishes for maintenance and lowering the maintenance time when it comes to the managing a huge ActiveMQ infrastructure. Malmberg for, again, reducing the maintenance and stability, introducing a better stability for their infrastructure. Dealer.com and Benched, which basically use those services as use that service as a hybrid cloud in the hybrid cloud scenario, and allowed for them to implement this migration in a fully controlled and predictable way. So let's talk about operations. If you have any questions, please let me know. Otherwise, we can jump into the second part. And we are jumping into a very important topic of high availability. So first things first, we've got ability to have single instance message broker. You see the difference. What are the major implementations? Either we can use the EBS or EFS, as I said, in the storage, on the storage layer. Still, we are dealing with one availability zone. And when it comes to the Amazon EBS, it is connected with the given availability zone. So the EBS volume resides in the same availability zone as the broker. When it comes to the Amazon EFS, it's fully replicated across multiple availability zones inside the same region that broker resides. So the main difference is when it comes to the durability and replication of the data. When it comes to this active standby, we've got only one option. We can leverage the Amazon EFS, and you can clearly see why. When it comes to the setup, we've got only one active broker, and the second one is waiting as a standby. And in this case, we are sharing the storage layer over the Amazon EFS service. So again, thanks to the service, we can replicate into the multiple availability zones, but also when active broker will not be available, thanks to the failover transport, we can actually start standby and resume from the same step based on the Amazon EFS data that are stored there. So that's why it's a highly available solution that allows you for highly available operations, not only the durable storage. When it comes to the broker lifecycle, I mentioned that it's very important to define a maintenance window, and also it's very important to actually understand that all changes require broker restart. And if you made any changes, those changes are waiting in a pending state, and you can apply them immediately or wait for a next maintenance window. If you would like to apply them immediately, broker will be rebooted. So it means that it is clearly visible for you that why it is important to have active standby setup for your installation. because there is no other way to introduce any configuration changes without downtime. If you like to rely on availability without downtime, you need to have setup that is relying on Amazon EFS, and you need to have active standby. Otherwise, every single reboot needs to be done out of the office hours, and that will involve downtime anyway. And this yellow decision box, when to apply changes, can be actually decided when we are applying those changes in the UI or over the API or console. So basically, you can schedule like in the RDS case, you can schedule the changes for immediate apply, to be applied immediately, or to be applied in the next maintenance window. Let's talk about pricing. So there's a free tier available, so that's one thing that is great. But you are paying for 3 components, depending on your configuration, of course, but you've got 3 components available. First things first, you are paying usage on hourly basis, and you need to be aware that you are paying for 2 instances for the active standby, because they are still running both at the same time, even if the one is active and visible for us. So if you would like to have a highly available setup, you need to be aware that you are paying for 2 machines anyway, like in the RDS case as well. Then you are paying for storage, either EFS based or EBS based, and you are paying data transfer between availability zones if you are using active standby, because the data transfer in AWS, when it comes to data in, it's free. When it comes to data out, it's paid with a different pricing table, but we don't have any out data when it comes to the going out from AWS. Still, transfer between regions and between availability zones is paid. So you need to be aware of the fact that this transfer between availability zones is also paid, and that may be a component for you. And we arrived to a topic that is pretty important if you would like to have highly available setups that allows you for having a mesh of multiple brokers. And we've got 2 ways to actually introduce those changes. We can use the sample blueprints that are available in Amazon MQ, and you can see the 2 available blueprints, which is mesh network of single instance brokers and mesh network of active standby brokers. And all those meshes blueprints are actually managed via CloudFormation. They will automatically deploy for you and handle the whole provisioning. But if you would like to configure something more complicated, it is also possible, but you need to take care about the AWS CloudFormation and automatic provisioning on your own. What is the difference between those 2? I think you can see you can have active standby setups, and each one can have multiple availability zones redundancy. When it comes to the single instance brokers, you have 3 single instance brokers that are connected in a mesh and available. They can be available on a single availability zone or multiple availability zones, depends on you. Still, you will pay for the transfer between them and so on and so on. If you would like to migrate, or sorry, not migrate, they update the configuration, still that will require a reboot, and you will don't have standby for that particular broker. So that's something that you need to evaluate if you would like to use one of another. But when it comes to network of brokers, the most important thing is the topology that we can choose. And some of you actually see the pattern and probably feel that there is a support for multi-region setup, but I will talk about this as a last element when it comes to the topologies. First, I would like to explain what are the differences between the topologies available for Amazon MQ. So first kind of the topology that we have available is a duplex bidirectional topology. So we've got two brokers that are connected together, and they are exchanging messages both between the brokers in both ways. You can have also non-duplex unidirectional topology, which is basically a replication from one broker to another and just connectivity between one broker or another. Those two scenarios are pretty interesting because they are enabling much more complicated topologies based on those. The first more complicated one will be mesh topology, and you saw that when it comes to the blueprints, you had those meshes defined either with the active standby or single instance. You can see that there are three connections between multiple brokers, both bidirectional connections, so you can actually exchange messages in in the triangle. When it comes to the more complicated topology, I would like to explain what is the hub and spoke. When we have one central hub, which is named broker 1 in this place, and then we've got spokes and satellites, you may call them as well, the brokers that are connected with the hub and expose the additional messages to the other parties. So this hub and spoke is also an important and very interesting topology to have. Next one is concentrated topology, when we have multiple messages sent from one concentrator to the smaller amount of brokers available in one direction. So you can see that we are actually replicating from each individual broker 3, 4, and 5. We are replicating messages to the two brokers that are available on the top, so broker 1 and broker 2. And this is a unidirectional relationship. And last but not least, I would like to explain that you can also apply those network of brokers between multiple regions. So in this case, you've got 4 brokers that are connected, each with everybody. And you can see that we are using actually 2 different regions, US West 2 and US East 2, and different availability zones even between those brokers across one region. You can even place all those brokers all in 4 different regions if you would like to. The major drawback and the major challenge is to A, pay for the network transfer between regions and availability zones, and B, you need to be careful with distributed transactions because they may introduce some potential problems and slow starts and deadlocks and so on and so on. So if you are using distributed transactions in either JMS or NMS, be careful with those kind of topologies because they may introduce problems to you. So we finished the topologies and network of brokers. Let's talk what options do we have when it comes to the scalability and how to actually guarantee the low latency or high throughput. When it comes to the low latency, the biggest interesting point is that all those wire protocols that I've described, they are leveraging always on connections between the brokers and applications. So thanks to handling stateful connections, AmazonMQ reduces the time between the publish and consumption. And if the low latency is important for those applications, you can actually use the AmazonMQ for that. And many companies that leverages this service for financial transactions or sports scoring and so on and so on. Second point when it comes to scalability is high throughput. And when it comes to the high throughput, you've got either in-memory or EBS storage. When it comes to in-memory, you've got only the volatile option, but still you get a very impressive throughput. When it comes to EBS, you've got durability across one availability zone. And if you would like to have a redundant and highly available option of multiple brokers, you need to implement network of brokers, for example, across multiple regions, across multiple AZs, and that will also change your behaviors and traits when it comes to how the cluster will behave. However, that may be your only option when it comes to the preserving high throughput, such like I explained, so 500 messages per producer per second when it comes to the 1 kilobyte to the message size. And for the high volume order processing, like stock trading, text processing, and so on, many companies are actually using Amazon MQ for those use cases as well. And also, there is an interesting point that is raised in the documentation that throughput optimized message brokers may reduce the number of brokers that are required, which may reduce the overall cost, because even the bigger but still not as big message broker with high throughput may handle more transactions, may handle more messages than a network of brokers that are in a different instance type, but still there are many more of them. So bear in mind that maybe one bigger message broker may be a better idea when it comes to cost efficiency. Are there any questions regarding the part 2? Okay, so far so good. So either you are not there or you are not listening, maybe. I hope you are still there with me. So let's start the part 3 when I would like to explain the best practices that are associated with the service. So when it comes to the comparison between all those 3 services that we explained over the past 3 weeks, I would like to remind you the difference between Amazon SQS and Amazon SNS first, and then we will go to comparison between SQS and MQ and SNS and MQ. So SQS and SNS are different in a sense that if you need topics and subscription capabilities, which is push-oriented messaging model, use SNS. That should be your choice. If you need queuing capabilities and poll-based messaging model, and also persistence, consider using Amazon SQS. So push versus poll, the choice is simple, and the reasoning behind this choice is also very simple. Those services are dedicated to those 2 different use cases. But how those things different when it comes to Amazon MQ? If you need queuing capabilities, but you have an existing messages broker available, migrate to Amazon MQ. And so far so good. We actually expect and know that Amazon MQ has those queues. We expect actually having queues from messaging server. But if we are building new or rewriting an existing application to leverage the AWS platform, maybe it will be a good idea to actually migrate to Amazon SQS, because it's more scalable and less operational heavy, in a sense that Amazon MQ is still fully managed, but you need to take care about capacity provisioning, you need to define maintenance windows, and so on and so on. So SQS is even more managed service than Amazon MQ when it comes to the shared responsibility principle that I described in the AWS certifications sessions that are available on this channel as well. So when it comes to this shared responsibility principle, Amazon SQS is more managed service than Amazon MQ, and you may benefit from using that service. Also when it comes to the pricing model, because there's clear difference between Amazon MQ and SQS, in a sense that in Amazon MQ you are paying for the machines that you are using, but still you need to run those machines 24/7. but for Amazon SQS, you are paying only for what you are using, which is totally different. But still, if you have existing broker, migrate to MQ. If you are rewriting or building a new application, maybe SQS will be a better choice. So far, so good. What is the difference between SNS and MQ? Well, on Amazon MQ, we also have topics and subscriptions. That may be surprising for some of you, but it actually supports the same push notification model. So if you would like to have no topics and subscriptions and you have an existing broker, migrate to Amazon MQ. That will be much cheaper and much easier. If you are building a new or rewriting an existing application to leverage AWS, consider using SNS. The same story like with the SQS. Here in this case, if you have an existing message broker or you would like to leverage a hybrid cloud scenario, Amazon MQ is the better choice for you. When it comes to the building a new application or rewriting an existing one, I would consider using SNS. And that's actually the reasoning behind origination of this service. Because as I explained in the beginning, Amazon MQ main use case is to support easy migration to the cloud and to support environments that are having existing message brokers and message-oriented middlewares. Regarding migrating to Amazon MQ, there are a few problems that needs to be solved, and those migration scenarios depends either on if you would like to have a downtime or not, if you would like to preserve message order or not, and so on and so on. If you would like to have FIFO and preserve message order, unfortunately there is no way to do this without downtime. You need to involve with downtime when it comes to migration. If you can have unordered messages, you can do it without interruption. The whole process is very well described in the documentation. There is a link below this slide that links to the official documentation and which describes the whole process in a very detailed way. There's one important thing when it comes to connectivity, and it's also related with the way that we are consuming the whole service. So let's talk about the obvious stuff first. The best practice when it comes to connectivity is to actually leverage the connection pooling, because you will actually spend less time on initializing the TCP connections and so on and so on, but also to leverage the failover transport if you have multiple brokers. The failover transport is pretty easy to be configured on the Amazon MQ side. It's basically this, you can configure it in the same way like with the ActiveMQ. So you are having this failover function in the configuration, and you actually passing multiple URIs, multiple addresses, and you are randomizing the access between those two. And that enables failover transport on Apache ActiveMQ side. So having those two things implemented, there is one additional thing that you need to remember. So if you will create and provision Amazon MQ broker, you will see this broker in the user interface in the console, but it will create under the hood an elastic network interface that actually connects the service code with your customer VPC. And do not mess with this ENI at all. Do not modify it, do not delete this network interface. Otherwise, you will introduce a permanent loss connection between your VPC and your broker. And sometimes, in some cases, even support will be able to help you. So do not mess with this ENI because you will need to move those brokers between the VPCs, which may sound impossible. And you will need to reach support in order to create a secondary elastic network interface just for the migration purposes and so on and so on. Been there, done that. So be careful with this. When it comes to security, obviously that like all other services available in AWS, it's actually secure by default. It supports encryption at rest. We use the KMS service, so key management systems. It also supports encryption in transit for TLS and SSL for supported protocols. Keep in mind that when you are using EFS storage, you need to grant access to our AWS KMS key for that service. So if you are actually configuring the encryption for Amazon MQ, you need to have access to the key, and you need to give that access to that key to the Amazon MQ service via service linked role in IAM. So that's a very important point about being able to access the KMS key. When it comes to the best practices, how to expose your clusters, your message brokers, always prefer brokers without public accessibility. It is possible to expose your message broker publicly. I think I don't have to explain how bad this idea is. Sometimes you have to, I understand that, but prefer brokers without this feature. I don't know why, but by default, maybe that's because that's the maybe that's the default of the Apache ActiveMQ as well, because I clearly think that it is. I don't know why, but there is no configuration of the authorization map. So reach out to the documentation and read how to set an authorization map for Apache ActiveMQ, because that will secure your broker and disable the anonymous access. Additionally, if you are using one protocol only, just block the unnecessary ports via VPC security groups. That will increase the security, and that will also eliminate some kind of issues and errors maybe in the future. If you would like to have a fully complementary encryption in transit that is safe for the sniffing, you need to implement client-side encryption, because currently Amazon ActiveMQ does not support client certificate authentication. So bear that in mind, that you cannot use client certificate authentication currently. And additionally, Amazon MQ does not support plugins for Java Authentication and Authorization Service, so JAS. And that's a bummer, because in many cases that would be the easiest way to actually introduce some additional security and authentication layers. But yeah, for now, we actually cannot use that. And last but not least, I would like to explain you how to build an AWS Lambda consumer that will work with the Amazon MQ. So as Amazon MQ exposes protocols that are stateful, you may think that it would be impossible to actually have a Lambda consumer, but it's actually pretty easy to set up if you think about it. So on the right side of this slide, we've got a typical setup with active standby and EFS storage here, which is actually irrelevant, because we can actually do the same thing with single instance, with network of brokers, and so on and so on. The main point here is that we've got the message brokers that are exposing the AMQP line, which is the stateful TCP based connection, and we would like to connect to that broker from a Lambda. How to do that? Obviously, we cannot start the Lambda and hang the unlimited amount of time on this connection to fetch the newest messages, because Lambda is limited and you can actually invoke just for the 15 minutes at the moment, which is the maximum time. So only for the 15 minutes we can open this stateful connection, and then we can actually stop listening. But what if we can actually leverage the Amazon CloudWatch trigger, which is in this case a scheduled rule. So every 5 minutes, CloudWatch will trigger Lambda, which will be actually an consumer that opens the channel to the message broker, fetch all the messages that are available, pass them around to a third-party system, which is in this case marked like the other system, and just finish their lifetime and lifecycle. Then after 5 minutes, we will spawn another consumer Lambda, which fetch the messages via AMQP, and then we will pass them to the other systems. And here we can use the fan out over the SNS, and we can use the async, whatever you would like to. The main point is that you can actually trigger the Lambda with the Amazon CloudWatch events, and this Lambda will open the channel even over the stateful connection to a broker, fetch what is available, and send back to the downstream. The biggest problem with this kind of solution is that we are losing the ability to handle the errors properly, because the downstream systems needs to handle this reliably, because we actually acknowledge those messages here and they will be removed from the queues or from the topics. So downstream systems needs to process those messages reliably and without any errors. That's one thing that you need to remember. But other than that, it's pretty useful a technique to be implemented, because otherwise you may think that it is impossible to actually connect with Amazon MQ from AWS Lambda, but that's not the case here. Okay, so that's basically everything that I prepared today. If you have any questions, that would be the time to ask them. So feel free to do it on the chat. In the meantime, I will remind you that next week we will meet on Tuesday. So Flashpoint is asking, isn't message broker normally responsible for routing and data transformation? It looks like a simple queue here. So you can actually have all those complicated routings and data transformations inside the ActiveMQ like you would have in the normal case as well. So you can have queues with the queues, the routing between them, and so on and so on. You can implement everything inside your message broker, but still at the end there needs to be a consumer on the other side, and then there needs to be a producer on the side. So everything that is supported and implemented in the ActiveMQ can be normally replicated with this Amazon MQ scenario as well. The main point is that I do not focus on explaining the ActiveMQ here, because that's basically over the current scope. But yeah, still you have the same capabilities that you would have in the normal Apache ActiveMQ implementations. So I hope that this answers your questions. It's not a simple queue for any case. You can implement very complicated scenarios based on the, as I said, JMS, NMS, and all those distributed transactions that you need to require to handle, and so on and so on. Everything is there. I just didn't describe it. I just explained it from the AWS perspective. So it's fully supported like in the open source version of the Apache ActiveMQ. Does it make sense? Okay. Are there any more questions? So in the meantime, I will just remind you that in the next week we are meeting not on Monday, but on Tuesday, like usually. And next week we'll talk about Kinesis data streams. And in the 2 weeks, we will talk about EventBridge, which is a very important service when it comes to the serverless, but also it's very important and interesting because it introduces the ability to have a centralized event bus between AWS, your microservice architecture, and also third-party services like software as a service solutions and others. But that will be covered in 2 weeks from now. In the next week, we will talk about Kinesis data streams, which are also interesting service. Okay, so I suspect that there are no more questions today. So yeah, that's everything what I prepared. First, thanks for this episode. Stay healthy, and I hope we will see in the next weeks. Cheers and thank you.